So hi everyone, I'm Matteo Franz, and today I'm presenting Conversational OLap in Action, which is a work I did with Enrico Gallinuzzi and Matteo Golfrelli from the University of Bologna. So our goal is to query multidimensional cubes through natural language, since natural language is something that we know from our childhood. Indeed, OLap do provide some low-level operator to query multidimensional cubes. However, users do need to have some knowledge on the multidimensional model or even to have some programming skill in order to run query against the multidimensional engine. Also, in some scenario, and free interaction is mandatory, for instance, in case we want to apply analytics in augmented reality or with smart assistant. So we introduce Cool, that is a framework for conversational OLap. The architecture of Cool is composed by two phases. The offline phase runs just one time when we first populate our system, and then the online phase runs each time the user issues a new query to the system. So the goal of the offline phase is to populate what we call the knowledge base. So where we put all the tokens that actually contribute to the translation process. That knowledge base is populated either automatically, so we have some extractor that, given our cube or our data warehouse, extract the values as well as the metadata, like as a hierarchy structure or aggregation operator of the measure. And also we optionally support the possibility to actually populate the knowledge base with some synonyms from open data ontologies, but that is not mandatory. Then, in case users have really specific lexicon, they can also provide their own synonyms manually. As to the online phase, so we start with a natural language query from the user. If it is spoken, then we first apply a speech-to-text transformation, and given the text, then we apply some interpretation that is based on a formal grammar. So the output of the interpretation is a parse forest. However, it can happen that the parse forest, let's say, is somehow broken, since in the test there might be some ambiguities or inaccuracies. So the next step is actually disambiguation, where we ask user to incrementally refine the parse forest until we obtain a single parse tree. And that parse tree also acts as a context in case we want to run incremental query against the database. So we issue a long full query, and then in the next step of our interaction, we just partially refine that query. Given the parse tree, then we translate the tree into SQL, and we execute the SQL and return the result to the user. So the grammar is a formal grammar, and you can see here on the left of the slide, that is say, a partial representation of our grammar. And we are not going into the detail, but I would like to give you the intuition behind the grammar. So the idea is that given the raw text from the user, so return the average sales in 2019 per store region, first we apply some mapping and tokenization. So we map each part of the text to the most similar entity from the knowledge base, and then given the list of entity, then we apply our parser with grammar in order to get the parse trees that represent the syntax of the queries that the user has expressed. Also, we run some experiment with 40 users having different OLap skill from low to high. Users were asked to translate Italian analytic goal into English, and they provided good feedback both on the interface as well as on the interpretation accuracy that is around 91–92%. So let's stop talking and let's jump into action. This is an interface to Cool. As you can see, the interface is minimal and pretty much straightforward. At the center of our screen, we have the DFM representation of our multidimensional cube, where the rectangle represents our sales that are described by three measures: store sales, store cost, unit sales. And then we have the attributes that are within hierarchies, meaning that, for instance, we can group by sales by month and sum the unit sales that have been sold in each month. Then below the DFM, you see a text box where user can either manually write the query or use our microphone to enables the speech-to-text module. So let's try some example. I would like to show you 2 different OLap sessions within Cool. Can you please return the amount of store sales of beer and wine by country? As you can see, the Cool actually translated our speech into text. Then we just run the query, and as you can see here below, the Cool return the result. So the sum of store sales by country, in this case, we just have sales for USA. And the intuitive thing is that also we map all the pieces of our query into the DFM. So since we asked to sum the store sales, as you can see here, store sales are highlighted in green. Then our query also consider the country, so we are grouping by country, so country becomes green, and also we can see here that the product category is set to beer and wine. So now we are seeing the sales for product category beer and wine, even if we didn't explicitly say that beer and wine is actually a product category. So let's try with another tab of our OLap session. And what about beer alone? So now we're asking the system actually to only show the sales for beer. So he knows that beer is a product subcategory. So as you can see here, the sales now dropped from almost 40,000 to 29,000. Then we can do the last step for this session, for instance, break down the result by gender. Again, we run the query, we added the attribute gender to the group by clause. So now you can see that the sales are also broken down for gender, and for female, the sum of beer sold is actually slightly higher than the sales for male. And now let's try with the second OLap session. Get the sum of unit sales in USA by month. Then we run the query. This time something different happened. So as you can see here, we have the country equal USA as well as store country equal USA that are both blinking. Cool recognizes this ambiguity and asks to the user to disambiguate it. So to choose one of the 2 attributes that we want to refer to. So suppose that we want to refer to country, we just click on country and we disambiguated the query. So now as you can see, the query runs as expected. Then we can also try to add another step to our session. For instance, can you also add the store sales? If we run the query, actually we see that now is store sales that is blinking. Again, Cool recognizes a different type of ambiguity. So in this case, we are trying to add a new measure, but actually we are not aggregating the measure. So Cool now lists the possibility either to drop the new measure or to select one of the allowed aggregation operator. So let's say again that we want sum the store sales. We run the query, and the query runs and ends well as expected. Then also Cool provided other ways to provide incremental queries. Now we do not have time to go through all of them, so I'm just giving you a grasp. For instance, remove the filter on country. And as you can see here, country before was set to USA, now is blank, meaning that we are not applying a predicate to our query anymore. So this is pretty much the flexibility of Cool. So we are capable to handle incomplete queries as well as some ambiguity in the values and much more. So please go and check them in the paper. So thank you for the attention, and let me know if you have any questions.